Let's now see if we can convert a larger decimal representation to binary. So let's say that we have the number 114, and this is its decimal representation. See if you can pause the video and rewrite this in its binary representation. So I'm assuming you have at least tried. Now so we can work on this together. So as always, we just want to decompose this into the sum of powers of 2. And you can always decompose this, any number, into a sum of powers of 2. And we can once again just remind ourselves the powers of 2. 2 to the 0 is 1. 2 to the first power is 2. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. 2 to the sixth power is 64. 2 to the seventh power is 128, and that gets us large enough. We've already gotten larger than the number here. So let's see, 114 can be rewritten as the largest power of 2 that is less than or equal to that is 64. So we can rewrite it as 64 plus what's going to be left over, 64 plus 50. Now we're going to have to rewrite 50 as the sum of powers of 2. And let's see, 50 is can be rewritten as, see, the largest power of 2 that is less than or equal to 50 is 32. So we can rewrite it as 32 plus what is that? Plus 18. And now we have to rewrite 18 as the sum of some powers of 2. Well, 18, the largest power of 2 that is less than or equal to 18 is 16. So this is going to be 16, and then 16 plus 2. And lucky for us, 2, I guess not that lucky, we have to do this a good bit. 2 is a power of 2. 2 is a power of 2. So we can rewrite this. 114 is equal to, let me give myself enough real estate here, is equal to 64 plus 32 plus 16 plus 2 plus 2. I've just written 114 as the sum of powers of 2. And once again, we can view this as 164 plus 132 plus 116 plus 1, 2. Now we're ready to really write this in binary. So let's just write the different place values. So remember, this is the ones. This right over here is the ones place value, or the ones place, I should say. Let me do this in a different color. So this is going to be the ones. Then we're going to have the twos. Then we're going to have the fours place. Then we're going to have the eights place. Then we're going to have the 16s place. Tells you how many 16s are in this number. Then we're going to have the 32s place. How many 32s are in this number? And then you're going to have the 64s place. 64s. So how many ones do we have here? Well, we have 0 ones. How many twos do we have? Well, we have 1, 2. You're going to have 1 of something or 0. There's only 2 digits if you're thinking in binary. Now we have no 4s. No 4s here. No 8s. No 8s. We have a 16. We have a 16. We have a 32. We have a 32. And we have a 64. So in binary, the number 114 in decimal would be written as 11100110.